Hello everybody, and welcome to the continuation of the preliminary example on page 33 of the workbook. Hopefully by now you've taken some time and tried to estimate the volume of wood in the trunk of this tree. Okay, I want to emphasize again that there is no exact answer to this problem. You can't get a right answer. We're just being asked to estimate. So I'm expecting that probably all of you came up with a slightly different answer, different way of doing this estimation. Okay, let's talk together about one possible way of estimating. I'm not claiming that this is the only way or that it's the best way. It's just one way to do it. Okay, and my strategy is going to be to think of this tree in chunks. Okay, if we count them, we've got 1, 2, 3, 4, 5. Okay, and each of those chunks you can think of as approximately being a cylinder if you kind of come up with an overall average for the radius. So over to the right here, we're going to make a list of average radii. Okay, and I'd like to start actually at the bottom slice here. Okay, so if you look at the top part of this bottom slice, we've got a diameter of 6. Okay, so the radius at the top would be 6, and at the bottom we've got a diameter of 14, and so the radius would be 7 down there. Okay, so if we've got a radius of 6 up here and 7 down here, what would the average be? Okay, it would be halfway in between, so a radius of 6.5. Okay, so you can think of that bottom slice of the tree, its volume or its shape is approximately a cylinder that has a radius that's kind of halfway in between the two that we're given. So it might look something like, okay, this is going to make the drawing look a little ugly. Okay, you can see that I really am drawing challenged here. Okay, but what I'm trying to do is to draw a cylinder that has a radius of 6.5, kind of halfway between the radius at the top and the radius at the bottom, and then claiming that that cylinder is maybe a good approximation of that bottom chunk of the tree. Okay, now we're going to just do the same thing as we move up our tree. So moving to the next piece here, the top we have a radius of 5, and at the bottom we have a radius of 6. So halfway in between would be an overall average radius of 5.5. Okay, we're just going to keep doing that. So let's see. Here, radius of 4.5 at the top and 5 at the bottom. Average those, and we're going to get a 4.75 average radius. Okay, let's see here. 4 radius at the top and a 4.5 at the bottom. So overall average of 4.25. Okay, and then finally, very top slice, we actually have a radius of 4 at the top and the bottom. Okay, so we'll just take 4 as our average radius. Okay, and now to find an estimate of the volume, we're just going to think about the approximate volume of each slice. Okay, and let's see, we could either work our way top to bottom or bottom to top. How about if we go top to bottom? Okay, so starting with the first slice here, we just calculated an average radius of 4. Okay, so the volume that we should get is pi times 4 squared times the height. Remember that formula for the volume of a cylinder? So pi r squared times the height. What is the height of this slice that we're looking at? Okay, well, they kind of told us that in the problem. We're measuring diameters every 60 feet, so the height of each slice is 60 feet. Okay, so pi times 4 squared times 60. Okay, and then we move on to the next one here. So there we have an average radius of 4.25 times 60 again. And we're just going to work our way down one by one. Okay, I'm going to go in and just fill in the rest of these. Okay, so then we come to pi times 4.75 squared times 60, pi times 5.5 squared times 60, and then finally, pi times 6.5 squared times 60. Okay, we would like to calculate this. Okay, and just to save a little bit of writing, you might notice that in every single one of these terms, we've got a pi and a 60. So we could factor the pi times 60 out and just add up the squares of the radii. Okay. And oh, actually, I just noticed one little notation issue. I should not write volume equals. I should write volume as approximately. Okay, so we're approximating here. We're not getting an exact number. Okay, and then at this point, it's a matter of going to your calculator and just figuring out what this works out to be. And what you're going to come up with is this number. Okay, my question to you would be, what would the units on this number be? How is volume measured? Okay, well, since distances are being measured in feet, this should be cubic feet. Okay, there's our best estimate of the volume of the wood in the tree. And again, when you did this, you very probably came up with a different number, and that's okay. That's totally okay. There's no one correct answer to this. You might ask yourself if our answers look like they're in the same general ballpark as each other.